It is the world's most beloved indulgence, a substance that has toppled empires, fueled revolutions, and comforted billions. It is the language of love, the currency of celebration, and a marvel of modern engineering. We are talking, of course, about chocolate. But before that silky, rich square melts on your tongue, it undergoes a brutal and beautiful transformation. It begins its journey deep in the equatorial rainforests, but its destiny is fulfilled here, inside this colossus of steel and steam. Welcome to the Mega Factory, a multi-million-dollar facility that never sleeps. Here, science meets art on a massive scale. Every day, 50 tons of raw, bitter seeds are transmuted into pure confectionery gold. It is a process of extreme heat, crushing pressure, and microscopic precision. Today, we are granted exclusive access to follow the incredible journey, from the humble cocoa bean to the perfectly wrapped bar. Step inside the machine. The journey begins at the loading dock. These burlap sacks have traveled thousands of miles from the Ivory Coast, Ghana, and Ecuador. Inside them lies the raw heart of the operation, the Theobroma cacao bean. To the untrained eye, they look like dusty pebbles. They smell acidic and vinegary. There is no hint of chocolate yet, but inside these shells lies the potential for greatness. The first step is purification. The beans are dumped into the intake hopper, a hungry beast that swallows thousands of pounds per hour. But the beans are not alone. They come with travelers from the jungle: twigs, stones, dust, and fibers. The factory employs a multi-stage cleaning system. First, massive vibrating sieves shake the beans violently, allowing the smaller debris to fall through mesh screens. Next, powerful magnets strong enough to lift a motorbike scan the flow, pulling out any metallic fragments. Finally, jets of air blow away the light dust. Only the perfect beans are allowed to pass. The factory is ruthless. If the raw material isn't perfect, the final chocolate won't be. Cleaned and sorted, the beans are now ready for their trial by fire. This is the roasting room. If the bean is the body of chocolate, roasting is its soul. The beans are fed into massive rotating drums similar to giant coffee roasters, but on an industrial scale. The temperature here is critical. It climbs to between 120 and 150 degrees Celsius. This isn't just cooking, it is chemistry. As the heat penetrates the shell, a phenomenon known as the Maillard reaction begins. Amino acids and reducing sugars interact, unlocking over 600 volatile flavor compounds. The acidic vinegar smell evaporates, replaced by the deep, intoxicating aroma of roasted cocoa. This is the moment the factory starts to smell like heaven. The roast master monitors the time to the second. Roast too long and the chocolate will taste burnt and acrid. Roast too short and it will be sour and grassy. It is a multi-million-dollar gamble played out every hour. The beans are now roasted and fragile, but we can't make chocolate yet. We need to get inside. The outer shell of the cocoa bean is inedible. It must be removed to reveal the prize within, the nib. This process is called winnowing. The roasted beans are hurled against breaker plates, shattering them instantly. But now, we have a mix of heavy nibs and light shells. How do you separate them? The answer is gravity and wind. High-velocity vacuums suck the lighter shells up and away, destined to become garden mulch. The heavier, darker nibs fall downward. These nibs are pure cocoa. If you ate one now, it would be crunchy and intensely bitter like a coffee bean, but earthier. These nibs are the building blocks of every chocolate product on Earth. Now, physics takes center stage. The nibs are solid, but they contain a secret: they are 50% fat. This fat is known as cocoa butter. To release it, the factory uses brute force. The nibs are fed into the grinding mills. Heavy granite or steel discs crush the nibs against the mill floor. The friction generates immense heat. Watch closely. As the heat rises, the cocoa butter inside the solid nibs melts. The dry, crunchy solids dissolve into a thick, dark sludge. This is chocolate liquor. Despite the name, there is no alcohol here. It is pure, liquid cocoa mass. At this crossroads, the factory must make a choice. This liquor can be pressed to separate the butter from the powder, or it can be used whole to make dark chocolate. For our journey, we are making the world's favorite milk chocolate. Pure chocolate liquor is bitter. To make it palatable, we need to sweeten the deal. In the mixing tank, the recipe comes to life. Tons of white sugar, powdered milk, and vanilla are dumped into the dark liquor. Giant paddles, the size of boat oars, churn the mixture. It looks like thick, coarse dough. If you tasted it now, it would be gritty, like sand. The human tongue can detect a particle that is 30 microns wide. To make chocolate silky smooth, we need to get smaller than that. Enter the refiner. This machine consists of 5 heavy steel rollers stacked vertically, spinning at different speeds. The chocolate dough is forced between them. The pressure is immense. The rollers crush the sugar and cocoa particles down to less than 20 microns finer than a human hair. The coarse dough is transformed into a fine, dry flake. It looks like dust, but it tastes like potential. We have the texture, but the flavor is still sharp. To mellow it out, we enter the most time-consuming part of the process, the conch. Named after the seashell shape of the original machines invented by Rodolphe Lindt in 1879, conching is essentially a long, heated massage for the chocolate. The dry flakes are poured into these heated troughs. Massive granite rollers or metal arms plow through the mixture, back and forth, for hours, sometimes up to 72 hours for luxury brands. This constant agitation does 3 things. First, the friction generates heat, melting the cocoa butter again and turning the powder back into a liquid. Second, it coats every single sugar particle in fat, creating that velvety mouth feel. Third, and most importantly, it aerates the chocolate. The harsh acids and moisture evaporate, leaving behind refined, creamy, and complex flavors. This is the difference between cheap chocolate and luxury chocolate. Time. The chocolate is now delicious, but it is chemically unstable. If we let it cool naturally, the cocoa butter will crystallize unevenly. The result would be a dull, grayish bar that crumbles in your hand and melts the moment you touch it. To get that glossy shine and that satisfying snap, we must align the crystals. This is tempering. It is a precise dance of temperature. The liquid chocolate travels through a heat exchanger. It is cooled down to 27 degrees Celsius to form specific crystal structures, then warmed back up slightly to 31 degrees to destroy the unstable crystals, leaving only the stable beta V crystals. It is molecular engineering. If the temperature deviates by even 1 degree, the entire batch is ruined and must be melted down to start again. The tempered chocolate, now stable and glossy, is pumped to the molding line. This is the speed run. The depositor, a robotic head with hundreds of nozzles, hovers over the empty plastic molds. With a pneumatic hiss, it injects the exact grammage of chocolate into each cavity. Zip, zip, zip. But there is an enemy: air bubbles. To defeat them, the filled molds pass over a vibrating table. The entire conveyor belt shakes violently. Watch as the air bubbles rise to the surface and pop, ensuring the chocolate is dense and solid. The molds then enter the cooling tunnel, a 100-foot-long refrigerator. Over the next 20 minutes, the chocolate contracts as it cools, pulling away from the sides of the mold. At the end of the tunnel, the molds are flipped upside down. Click-clack. The bars fall out effortlessly. They are perfect, shiny, solid, and uniform. But the clock is ticking. Chocolate absorbs odors and melts easily. It must be protected immediately. We enter the packaging zone. This is a blur of motion. Mechanical arms align the bars into single file. The wrapping machines are a marvel of robotics. They can wrap 500 bars per minute. Foil is cut, folded, and sealed faster than the human eye can track. Sensors check every bar. If a wrapper is misaligned by a millimeter, a jet of air blasts the rejected bar into a bin. The quality control is absolute. From a dusty bean in the jungle to a gleaming, foil-wrapped treasure, the journey is complete. What started as a bitter seed 3,000 miles away has survived fire, crushing force, and microscopic refinement. It has passed through a gauntlet of multi-million-dollar machinery to become something simple yet profound.
This factory produces 2 million bars a week, enough to wrap around the city twice. But for the consumer, the numbers don't matter. The science, the chemistry, and the engineering all fade away. All that matters is that moment of silence when the wrapper tears open, the snap echoes, and the taste takes over. This is the magic of manufacturing. This is the chocolate empire. Fade to black.